To find out refractive index of a prism practically. So a prism basically have two triangular surfaces and three rectangular surfaces. First, place the triangular base of a prism on a drawing board. Here I have taken a thermocol sheet. Next step, draw the boundary of the prism using a pencil. I am drawing here for clarity with a sketch. Now you find a triangle. Let us name this triangle as ABC. Now the second step is drawing normal to the surface. So here to the surface AB, I am drawing normal by using a protractor. So the normal is perpendicular to the surface. In order to measure angle of refraction and incidence, we need a normal. So here is the normal. Now let us take any suitable angle. I am taking now 30 degrees of angle. Now remember, always angle of incidence is to be measured from the normal. So I am taking from normal, which is at 90 degrees, from there to 30 degrees. So we will draw a point till 60 degrees here in order to get angle of incidence 30. So from here 10, 20, 30. So this is angle of incidence 30 degrees. Let us draw the incident ray at 30 degrees angle. So now the angle of incidence 30 degrees is ready. You may check from here 10, 20, 30. So this is angle of incidence 30. Right? Now the next step is we place the prism and then we use two pins. Actually, as there is a lockdown, I do not have pins. I am using some matchsticks instead. So the matchsticks are to be placed at two different points on the incident ray. So let me pierce this thermocol. Now I am placing these two matchsticks in the two holes. So as they have red heads, I can see them easily from the other side. Make sure the distance between the two pins is nearly 4 to 5 centimeters for our experiment. Now these two pins are seen from the other side AC of the prism. Now when we see the two pins from the other side, that is AC, you can find the images of the two pins, and we will take two more pins and we insert in such a way these two pins are also lying in the same line. See, this is the first stick I am using it, and I have placed in such a way this is coinciding with the line of the images of the first two pins. Now when we observe the two pins, these two pins are in the same line of the images of the first two pins, right? So we are observing the emergent ray. It is nothing but an emergent ray actually. So we remove the two matchsticks now, and we will join these two holes from the surface of the prism. It indicates that the light ray must have traveled from the two pins and then refracts into the prism and then came out. So emergent ray is seen in that direction. Let me take the first two pins as P and Q. Second two pins are R and S, which are the images. Now this is emergent ray. Now for finding out what is the angle at which the light ray has come out, angle of emergence, I need to draw first normal. So I am placing it exactly at the point where emergent ray started to 90 degrees. So we draw a normal now. When we draw the normal, we can measure the angle between the normal and the emergent ray, which is called angle of emergence now. So I am drawing a normal from the point of emergence. Now this is the second normal. Now the angle between the normal and emergent ray is called angle of emergence. So let us find angle of emergence now. Place the protractor. The 0, 0 point should be exactly the line of the emergent ray. Now 10, 20, 30, 40, 50, 60, 70 and two more lines. So 72 degrees is the angle of emergence. So this is angle of emergence 72 degrees. Now as we can see, the light ray must have traveled in this way inside the prism. So this is the line in which it must have been traveled. So I am now joining these 2 points using a pencil. So now I am joining these 2. Now this becomes refracted ray which is inside the prism, that we cannot see when the prism is there. So we will join it. Angle of incidence, angle of refraction, angle of incidence at the second surface, R2. So when we place it, the light ray must have traveled in that direction. In the absence of the prism, the light always travels in a straight line. Imagine there is no prism. What would be the direction of light ray? It must be traveled in a straight line. So it would have been traveled in a straight line in the absence of light ray. But it has deviated. So let me find out what is the deviation. I am drawing backward, emergent ray backward. So both are coinciding at a point, forming an angle here. We call that angle as angle of deviation, denoted by delta. Now you understood what is angle of deviation. So the light ray has deviated. Instead traveling in the straight line, it has deviated. So we will measure the angle by placing the protractor here, and this is almost 45. So this is the angle of deviation, which is equal to 45 degrees. So for angle of incidence 30, I got angle of deviation 45 degrees. So we will continue this experiment for various angles. I am not showing the rest of the angles. I have done with various angles like 30, 35, 40, 45. And if we tabulate all the values of angle of incidence and angle of deviation in a table, the values will be 30 degrees, I got 45. Now if it is 35 degrees angle of incidence, angle of deviation what I got is 40 degrees. Now if I take angle of incidence 30, angle of deviation what I measured is 38, and angle of incidence 45 degrees, I measured 43. So you might have seen the values change here, 32, 45, 40 and 38. Angles decreased and got a minimum value at 38 and again increased. Now if we plot a graph between angle of incidence and deviation by taking angle of incidence on x-axis and deviation on y-axis, you get a curve like this. Now the value of angle of deviation which is at minimum is 38. This is the way how we find out. And we also observe that the angle of incidence is equal to angle of emergence at that minimum deviation. Now let us write the formula of refractive index sin A plus dm by 2 by sin A by 2. So I have another video for derivation. You may go through it for derivation. For equilateral prism A is equal to 60. What we have measured for angle of minimum deviation is 38. So I am substituting the values of 60 and 38 in the values. 60, 38 by 2 by sine 60 by 2 is equal to sine 60 plus 38, 98. So 98 by 2 comes out to be 49. So sine 49 divided by sine 60 by 2 sine 30. Now with the help of logarithmic table or sine table, we will use sine table to find sine 49 value. So sine 49, you can see from here, sine 49 is 0.7547. So we will substitute the value 0.7547 in the numerator. So 0.7547 divided by sine 30 value is 1 by 2. So the 2 comes to the numerator, 2 into 0.7547. So on multiplication we will get the value 1.5094, approximately 1.51. So usually the glass has the same refractive index 1.51. This is the way how to find out refractive index. Thank you for watching.